If you need to find specific text within a file, you have several options. You're likely familiar with tools such as search or find that are available in most of the common text editing or word processing programs like Microsoft Word. In a lot of cases, those are sufficient, but as you continue to work with data, and especially if you find yourself working with large data sets, you'll encounter situations where you need alternative tools that offer more power and flexibility. For example, you might want to identify more complicated patterns of text by applying regular expressions, which aren't supported in all programs. Or you might have a data file that's simply too big to open and work on in most programs. Whatever the reason, grep is a command that can often provide that extra power and flexibility, and it's something you'll probably find yourself using frequently. The example file I'll use in this video is available at the link pasted in a comment pinned to the video. It's actually just a renamed version of the regexpractice.fa file we used in the previous video on regular expressions, so if you already got it for that one, no need to download it again. Here, I'm using the head command to preview the first 6 lines of that file. These 6 lines represent 3 DNA sequences. As consistent with FASTA format, each sequence is represented by 2 lines. These include one that starts with the right arrow, or greater than symbol, and that contains the name or description of the sequence, and then after that, one that has the sequence itself. Let's start with a simple grep command. Say you are interested in whether any of the sequences in this dataset contain the EcoR1 restriction site, which is the 6 base pair sequence GAATTC. This is a pretty simple search, and is something we could do with a search or find in most programs, but we'll use it here to get us started with grep. Running grep requires a few things. First, of course, is the command grep. This can be followed by 1 or more arguments, but those are optional, and we'll leave them off for now. The second required item is what you want to search for. In this case, GAATTC. Now, there are several ways we can provide this search pattern. We could do it like I have it here, or we could enclose the pattern in either single or double quotes. In this specific case, and in fact in many cases, any of the 3 options will work equally well. We'll take a look at why quotes matter as we go forward, but for now, we'll go ahead and put this in double quotes, as using quotes is a good habit to get into. The third item required to run grep is the text you're going to search in. You'll usually specify this by providing a name of a file that contains the text. In this case, it's grepexample.fa. So, now we have the 3 required elements for running grep: the command itself, the pattern of text we want to search for, and the set of text we want to search within. Running this command, we see the default output for grep is to print the lines from the text file that contain a match to the search pattern. In this case, there are 2 lines that have the EcoR1 site GAATTC. We'll now start to take a look at some of the arguments that are available within grep that allow you to modify its behavior. But be aware that what we'll cover here is just a sampling. There are lots of arguments available in grep. You can reference the manual page with man space grep at command line to get details on all of them. Let's go back and start again with the same grep command we just used. This time, imagine we wanted to locate the specific EcoR1 containing sequences in the file. We can add the -n argument, which prints the line number at the beginning of each match. Next, remember that this FASTA formatted file has a name or description line above each sequence line. What if we wanted to also obtain the description of each sequence that contains a match? The arguments A and B in grep allow you to define a number of lines of context after or before the match, respectively. So, we can add -B1 to include 1 line, specifically the associated name line, before each matching sequence. A third argument we can use is the color argument. Some environments will do this by default, but if not, we can specify --color, and the specific part of the line that matches is highlighted. What we've done here is a good start with grep, but we still aren't taking advantage of a lot of grep's functionality. For example, though it's not really clear from what we just did, grep interprets search patterns as regular expressions. By default, they are interpreted, at least in my implementation of grep, as POSIX basic regular expressions. However, the -E argument tells grep to use POSIX extended regular expressions instead. As part of the previous video on using regular expressions, we constructed a search pattern to identify any sequences in the data file that contain an N, while not matching any of the name lines, which also all contain Ns. Let's try the same search pattern we used in that previous video, caret, square bracket, ATGC, star, capital N, plus, here as our search pattern within grep. This time, it doesn't return any matches. This is because it's being interpreted as a POSIX basic regular expression, and that flavor of regular expression doesn't support some of the quantifier and modifier meta characters we're trying to use. If we run that same command, but include the -E argument, the search pattern is interpreted as a POSIX extended regular expression instead, which does support those meta characters, and we get the expected results, the 4 sequences in the data file that contain an N. Next, say we wanted to pull out just the sequences from this FASTA file, omitting all the name lines. Remember that the name lines are characterized by the greater than symbol at the beginning of the line. We can use that feature in combination with grep's -V argument, which reverses the behavior of grep and prints every line that doesn't contain a match to the search pattern. So, using the greater than symbol as our search pattern within grep, along with -V, should give us what we want. I've piped the results to head here so that I don't get all 100 sequences printed to my screen. That command is a special case that serves as one example of why it's a good idea to include quotes around your search pattern. If I remove these quotes, something entirely different will happen. I'm going to run this, but I don't recommend you do if you're following along, and it will be clear why shortly. When I do run it, I get an error that basically says I'm not structuring my grep command correctly. It's important to remember that the commands you run are initially interpreted by the shell, or think of it as the command line environment, and are then passed on to grep. Why this matters here is that the right arrow, or greater than symbol, has a special meaning at command line, and we've seen it in previous videos. It's used to redirect output to a new file. So, in this case, that's what gets interpreted first. That greater than symbol is interpreted in the context of redirection before anything happens with grep, and a new file is created with the name greppractice.fa. This is a problem here. If I now do a line count on that file, which originally had 200 lines, it now has 0 lines. The new file that was created for the purpose of printing the results of grep has overwritten my original file. What's more, because this was interpreted in the context of redirection of output, the only part of the command that was actually sent to grep is the grep-v part. This is one very specific example of a broader behavior that commands are first interpreted by the shell, or again, think of it as the general command line environment, before they are sent along to the specific command you're running. This sometimes has implications for the type of quotes you use to surround your search pattern within grep. To take a closer look at this, let's briefly step away from grep specifically and focus on the command line environment more broadly. We haven't addressed this yet, but you can create variables at command line. For example, here I'm creating a variable sample type and assigning it the string soil. Echo is a command that can be thought of as a print command. It prints whatever is passed to it to the screen. So, echo $sample type returns soil, as the $sign is the notation used to retrieve the contents of a variable. Note that each name line in the file contains a field that has information about the environment the sample came from, either soil or water. Imagine we wanted to pull out the data corresponding only to the soil samples and write that to a new file. We can use grep to do that by redirecting the output. We could simply type soil in as the search pattern, but to see one effect of the different types of quotes, we'll use the sample type variable we just created instead. Since we're going to match name lines with soil in them, we'll use the -A argument to tell grep to print one line of context after each match, which will be the associated sequence. Then we'll direct the output to a new file named soil.fa. Previewing this file shows that it has just the soil data, with some additional lines with 2 dashes that were added in as part of the -a argument that we'd probably want to go through and get rid of later. Now, let's compare that to what happens if we run the same command, but have the sample type variable inside single quotes instead of double quotes. This time, no matches are found, and so the file is empty. This is because the single quotes tell the shell to interpret the pattern literally. So grep ends up searching for $sample type, which of course doesn't occur in the file. In contrast, variables inside double quotes are interpreted at command line, and so in that previous case, soil was sent to grep as the pattern to search for. Like I said earlier, there are quite a few arguments available within grep, and you can see all of them on the grep manual page. However, just getting comfortable with the general structure of grep commands, and even just a few of the arguments we covered in this video, will put you in a position where grep will likely become a really valuable tool for you as you work with your data.